All right, so your calculator, whether a Casio or a TI-83 or TI-84 calculator, has a function like the normal CDF command, but it's called the tcdf command, or for the Casios is the tcd. But it computes a student t-distribution probability between a lower bound and upper bound for a specified degrees of freedom. And that this probability is in the form of tcdf, lower bound, then upper bound, then degrees of freedom. And pretty much it works the same way as a normal CDF. The only difference is that you deal with the degrees of freedom and not the mean and standard deviation. There are also a lot of online calculators out there. And for instance, your homework often has this calculator where it's set at normal distribution, but you can do t-distribution, then enter, say, degrees of freedom 10. Take your choice on what type of probability you want to find. I want to say the probability is, say, less than 1.1, just to pick something. And you can see that probability is 0.85. All right, let's try some. A t-distribution with 20 degrees of freedom is shown below. We want to estimate the proportion falling above 1.65. So in the calculator, I would choose the vars, and now I'm going to scroll down until I see tcdf. It's like option 6 here. And it'll ask me the same things we've done before. Lower bound is, I want to be above 1.65, so my lower bound is 1.65. The upper bound is 999. And I have 20 degrees of freedom. And with the older calculators, you might have to type it in just like this. tcdf 1.65, 999, 20. And we get 0.0573. So on this one, change it to 20 degrees. I want to be above, and what was it again? I think 1.65, yeah, that's what I thought. Compute 0.05728. Here's a different one, a t-distribution with 2 degrees of freedom. And you see that it's kind of very narrow, kind of thick tails. Estimate the proportion of the distribution falling more than 3 units from the mean. So that is, we have the lower tail and we have an upper tail over here. So for that, I would choose the tcdf. And then I want to be, I'll just find the right tail. So my lower bound is 3, upper bound 999, 2 degrees of freedom. Paste. And then times 2. And whoops. And I end up with 0.0955. So about 9.5%.